This is our video for lesson 6.2. This is radical and rational exponents. So before we start, I'm going to write a few things in here. If you're watching this for the first time, don't copy this down until I ask you to start. We're going to start by thinking about square roots. So that's going to be this symbol right here. So we would say this is the square root of 9. We'd say, well, the square root of 9 is what? So I would take a second here and pause and kind of think through this, try to remember everything you know about square roots, and then come back. So this would simplify to 3. The square root, I always think of this as a question. So when I see this symbol, I'm asking myself what number times itself equals what's inside, or in this case 9. So that number is 3, because 3 times 3 is 9, or 3 squared is the same as the square root of 9. So in the last section we were talking about exponents and powers, and square root is kind of the opposite of that. Squaring and square rooting undo each other. Just like if I had 3 squared is 9, but then I take the square root of that, we end up with 3. Or for some value x, if I square it and then take the square root, I'm just going to get whatever that value is, unless the original was negative. We're going to get to that here in just a second. So this is where we're going to start. We're going to go beyond just square roots now, and we're going to talk about nth root. So any number root. And we might say something like this. The nth root asks what number times itself n times gives us another number. And specifically, we'll be looking for that number under the symbol. There's a couple different ways we might write this. So when we have this symbol, we're going to write whatever root we want here. And then a is that number that we're trying to get to. Or as a rational expression, we would write it like this, as a fraction. And I'll explain both of those and what that looks like and what that means a little bit more in just a moment. Clarify here. This one on the left, this is our radical. And on the right, this is our rational. Sorry, this is getting a little bit scrunched up for me. Radical and rational. So, for example, instead of just thinking what number times itself once, we could think about what number times itself 3 times, or 4 times, or 5 times. Gives us some other number. So, for example, I'll do a couple examples over here. If I had the 4th root of 16, I could also write this as 16 to the 1/4 power. And if you put that in your calculator, that'll give us the answer that we're looking for. And this is 2 because we wanted the 4th root. We wanted what number times itself 4 times will give us 16. So 2 times 2 times 2 times 2 gives us that 16. That's why the 4th root of 16 is 2. Similarly, if I had the 3rd root of 27, now I'm looking for what number times itself 3 times would give me 27. And again, I could rewrite this as, I can leave it equals, that's true. 27 to the 1/3 power, which in this case would be 3, because 3 times 3 times 3 is 27. So you don't, some of these smaller numbers may be good. You may be able to come up with these on your own, but we'll be using the calculator for a lot of this. You really just need to understand what this notation means and what it's asking us to do. Let's move down to example 1. So this just says write the following radical exponents as rational exponents, then simplify. So we're just changing from one form to the other. And then you can put it in your calculator to get the correct answer. And we'll talk about how to do that. So when we don't have a number here, so like in this first example A, this is just the square root of 36. And like we said, that means what number times itself just twice. There really is, like, we don't write the 2 there because this is what we do the most often. This is kind of like the base version of the radical. So what number times itself twice will give us 36. We're going to see, we get some interesting cases that you probably haven't looked at before. When we have an even root, we have to consider negative numbers. 36, if we're just rewriting this would be 36 to the 1/2 power. We're going to get 6 or -6. It could be either one of those. And this is going to be true anytime we have an even root. And this makes sense if you think about it, because 6 times 6 is 36, and -6 times -6 is also positive 36. So whenever we have these even roots, if we're thinking it from this perspective, whether that original number was positive or negative, we could still get to 36. Okay, so we want to make yourself a little note here. Even roots give us 2 answers. And as we go through a few more examples, we'll see why that can't happen with odd roots. And we'll see some another idea here too related to this. But moving on to part B, now we're taking the third root of -27. So if I'm just going to rewrite this, that's -27 to the 1/3 power. And again, you could punch this into your calculator. We looked at this answer up above. So that's what number times itself 3 times equals -27. And this is going to be -3. So when we're doing it 3 times, if I start with a negative, negative times negative is positive, times another negative is going to give us a negative number. So that's why this rule here where we had 2 answers, that only applies to even roots. And then final one, the fourth root of 64. We could write this as 64 to the 1/4 power. And this is going to give us approximately 2.8 or -2.8, because that's that even root again, right? And that 4th power again makes sense, because if I started with a negative, if I have a negative times a negative, that's positive, times another negative, times another negative, we would end up with a positive number. So 2.8 to the 4th or -2.8 to the 4th will get us to the same place. Example 2, writing rational exponents as radicals. So now we're just going in the opposite direction. So we're just going reverse of what we did up above. And then we're going to simplify or evaluate here as well. So 16 to the 1/4, that's the 4th root of 16. And this would give us 2 or -2, or it's an even root, so we're going to get both. Both would be possible. -9 to the 1/2, so that'd be -9. This is just regular square root this is another one of those places where we end up with something kind of interesting. There's no number possible times itself where we can get a negative. So a lot of people want to say 3. Well, what is 3 times 3? That's positive 9. What is negative 3 times negative 3? Well, that's also positive 9. There's no number you can multiply by itself and ever get a negative number. So if we have an even root and an odd number, that's never going to work. Okay? This is not a real number. In the future, you'll talk about imaginary numbers, but that's not something that you need to think about right now. For right now, we just know that this is not a real number. Your calculator will probably tell you error. 64 to the 1/3. This is the third root of 64. Punch that into your calculator and you will get 4. All right, moving on to the back. Write the following in radical or rational form and then simplify. So I'm realizing now that as we're doing this, I didn't talk about how to write these in your calculator or how to punch this into your calculator. It's going to be easiest to just use the rational form. So like this, and then just type it into your calculator as you would a normal exponent. So for this example A, if we have 16 to the 1/4 in your calculator, you would punch in 16 and then use your caret key and then just in parentheses put your, not 1/2, 1/4. And I believe your calculator is just going to tell you 2. But you need to recognize now that that could be 2 or negative 2. So from that perspective, I think the rational form might be a little bit easier. Since you actually need to do it and punch it into a calculator and get an answer, but you can do this either way, and I'll write them in both directions. But this is a great place for you to pause and try these on your own, and then come back to this and just double check your work. All right, so we've got A is 125 and N is 3, so this is the third root of so this first one would be 125, and we're taking the third root, so this is what number times itself. 3 times gives us 125. You could have also written it like this, 25 to the 1/3 power, and that should be 5. Second one, this is the square root of 49. We don't normally write the 2, but you can. Or 49 to the 1/2, which is 7, because 7 times 7 is 49. And then finally, the fourth root of 81. So we've got the fourth root of 81, or 81 to the 1/4 power, and that would give us positive or negative 3. Okay, and this is how you're going to see this written most of the time going forward. So before we wrote 3 or negative 3, we usually just write it like this, plus or negative 3, right? Because that could be either one, because I have that even root. It's missing on my page, but there are a couple more on the paper notes for this section. You may have noticed that we've got a fraction. So like if I look up here, I've got 25 to the 1/3 power. Well, we've talked about powers, and this bottom number being a root, we can actually combine the two. I can write something as a power and a root. So here's the example that's going to be on the paper. If I had 16 to the 3rd power and the 4th root, we can write that in a way that combines both of these. And if you're evaluating this, it doesn't matter which order you do this in. So for example, you can take 16 to the third power, and then whatever you get, take the fourth root of that. Or you can take the fourth root and then raise it to the third power. Either way, it doesn't matter. But we can rewrite this as a combination of powers and roots as 16 to the 3/4 power, which means, just like we say there, it's going to be raised to the third power, and then we're going to take the fourth root. And when we do this, if you punch this into your calculator, you're going to want to punch it in just that way. So you're going to want it like this, where you put this as a fraction, and when you do, you should get 8. So in your calculator, you're going to want to do this, 16, and then you've got your caret in parentheses, 3 divided by 4, and that will give you 8. The other example we have here is 27 to the 4th power and the 3rd root. So again, that could be written as 27 to the 4/3 power, because the top number is always our power, the bottom number is always our root. And if you punch that into your calculator, I want to say 3, but let me just punch that in real quick, to the 4/3. Sorry, that is 81. Oh, that makes sense. It has to be bigger because it has a higher power than root. I was thinking 3/4 for some reason. Okay, so again, in your calculator, this is going to be 27 to the 4/3 power, and that will give you 81.